Dear children, I'm back again here with a new chapter, household circuit under the unit current, electricity and magnetism. This is the second chapter in the unit. The questions in the ICSE from this chapter will come in the section B in the form of question number 8. So question number 8 from section 2 of your ICSE question comprises of this chapter, household circuit. Now, if you see your book, the chapter is divided into two units. Unit A, where you have to learn about transmission of power and house wiring. And in unit B, you will be learning some essential components of house wiring system. Okay, now let me give you the basic idea about what we are going to learn here in this particular chapter, household circuit. In unit A, we'll be learning about transmission of power, how the power is transmitted and how the wiring is done in our home. Then in unit B, we'll be learning about some essential components of household wiring, that is about the wires, about the switches, about fuse, all right, and about earthing and all. Okay, so today we'll be focusing ourselves to unit A, transmission of power and house wiring. Okay, so now nowadays our life has become useless without electricity. We have made a very bad habit of depending ourselves with electricity or on electricity. Without electrical energy, we are not able to perform any tasks in our day-to-day life, isn't it? During this pandemic, we are staying back at our homes and we are attending this online sessions, and this is also possible with the help of this electricity. So now my question is, have you ever wondered how the electricity is reaching you? Yes, it comes through wires in your home, isn't it? There are poles in and around your village near to your house. Through the poles, the wire comes to your house, and that is how the electricity reaches to you. But have you thought from where this electricity is coming or how this electricity is generated? So today we'll be learning a bit introductory part of this generation of electricity. How is electricity generated? Now, electricity is generated usually in a power station. So a generation of electricity usually takes place in a power station. It's a place where electricity is generated. Do not use the word created, because electricity is a form of energy, and energy cannot be created nor it can be destroyed, but it can be converted from one form to another. So here we say generation of electricity means electricity is being generated, means it is converted from some other form of energy. So we are getting electrical energy from some other form of energy. All right, so in the power station there are generators which converts the mechanical energy, okay, mechanical energy into electrical energy. All right, so I will just try to show you the generators. So here this is how electricity is generated. Now electricity is generated, okay, from electric turbine. Now this is your generator, understand? So here you have the armature, okay. Armature means like it is a soft iron core which is winded open by some copper wire, and there is a big permanent magnet here, okay. And the interaction of this magnetic field, when this armature rotates, okay, and EMF is generated here, which in turn generates electricity. About this we will do in the next chapter called electromagnetism. Okay, so now basically we are just trying to understand how the electricity is generated. So electricity is generated in an electric turbine, okay, or we can say a generator. So when some kinetic energy is passing through this turbine. Now what is a turbine? Turbine is like a structure, fan structure. You have seen a fan, isn't it? So it looks somewhat like a fan. Now let me make a clear picture to show you what exactly a turbine looks like and how does it work. Okay, so I have a next slide here, and I hope everyone has seen this, isn't it? We usually get in the market where the vendors, okay, the hawkers are selling this. You have some Sophie liquid here, okay, and you blow to wind by your mouth, the bubbles come out, and I hope you have enjoyed with these bubbles, isn't it? But that is not our point. Our point is this one. So you have seen this, isn't it? And you have played with this also. When you blow the wind here, what happens? This starts to rotate. So exactly you can like compare the turbine of a generator with this device. Okay, so turbine also looks somewhat like this. So when you are blowing wind, so here we are blowing wind means wind energy. So the kinetic energy is in the form of wind. All right, so when wind energy, all right, is blown through this, what happens? This starts to rotate, isn't it? This starts to rotate. Are you getting my point? So wind energy is now converted here into what? A rotational motion, which in turn gives us some mechanical energy here. Are you getting my point? So the same thing happens here in your turbine also. So the source of kinetic energy can be of four types or four ways. One is through the steam, one is through the combustion of gases, one is through the flowing water, and the one is with the wind. All right, now in India usually, okay, electricity is produced by burning coals. So what happens is coal is used to burn like heat water, okay, which in turn boils the water and steam is produced. Now you know, you have seen a pressure cooker. All right, so there is a vessel, no, on the top there is a load. Usually we call it as a load, but in our general language we call it as a vessel, city, isn't it? But it's actually a load. So when you remove the load from a pressure cooker, what happens? The steam from the cooker oozes out with a great force. So that steam, okay, coming from the nozzle of the boiler is used to rotate this turbine. All right, so in India usually electricity is produced by burning coal, means with the help of steam. All right, second one is combustion of gases, like in generator. You have seen a generator, the portable generator that we use in our some functions, like in our weddings, in pujas, okay, pujama, biyama, we use no generators. The generators, now what do we burn? We burn kerosene or petrol, isn't it? So petrol and kerosene burns and it produces some gas, which in turn turns the turbine of the generator or the power generating station. Okay, then flowing water. You have seen dams, isn't it? In the dams, water are blocked and the level of the water in the river rises, and this has a stored potential energy in it, and when this water is allowed to flow, what happens? The potential energy converts into kinetic energy, and then this running water is used to run the turbine of the generators. Okay, so the nearest dam we have here is on river Tista, isn't it? It is managed by NHPC. The full form of NHPC is National Hydro Power, okay, Corporation. Clear? So that is our flowing water. Then we have seen windmills or electricity due to generated with the help of wind. Okay, so in this four way, okay, you can use these four ways to run this turbine. So when this turbine rotates, the shaft here or the axle is attached with the turbine. So when turbine rotates, this axle also rotates, and in turn the armature of this generator rotates, okay, in the magnetic field of this permanent magnets, and the EMF is generated or the current is generated, which is then supplied to the consumers. Now when I say supply to the consumer, it does not mean that it is generated in the powerhouse and directly it is supplied to us. No, that does not happen. Alright, now how is this transmission of power done? How is the transmission done? So transmission is done in various segments. Okay, various segments. Now we saw how the electricity is generated here. If you have any doubts, you can leave the comment, or you can ask me, or you can WhatsApp me. Okay, clear? So now here in the powerhouse, okay, in the powerhouse, what is done? Now let us do in a flow chart. Okay, so how is power supplied from the generator or the power station to the consumer, that is to us? So here I have 6 rectangular boxes. I will be making a flow chart here to show the different segments or the different activities that takes place, okay, before the power reaches to us. So the first rectangular box is our power station. So power station, this is our power station, and this is us, consumer, means the one who is using the current. So here you have 6, or you can say 5 slots or 5 activities that happens or that takes place before the electrical energy from the generator or from the power station reaches to us or reaches to you. All right, so in the powerhouse, okay, power is generated in the generator, okay, at 11 kilovolt. Kilo is a prefix which means 1000. So here you can see it is generated at 11,000 volt. Now the question arises, why at the power station energy is generated at 11 kilovolt? All right, now why it is at 11 kilovolt? Now why not below 11 kilovolt or above 11 kilovolt? Are you getting my point? Okay, so now it is not generated below 11 kilovolt because it leads to a very high amount of current, and to handle with large or high amount of current, it is very risky. Understand? And why it is not done above 11 kilovolt? Because when you have the potential difference at a very high potential difference, okay, potential difference is high, means there is a problem of insulation. There may be a leakage of current. Understand? So there might be a probability of having short circuit or leakage of the current. That's why it's like difficult to handle the power, okay, generation above 11 kilovolt and below 11 kilovolt in the power station. Understand? Clear? So 11 kilovolt is not directly supplied to us, that is to the consumer. So in between, these are the processes, okay, which we are now going to do. So first of all, what happens here is this 11 kilovolt is supplied to a station called grid substation. Okay, it is supplied to grid substation where the power is stepped up by using a step up transformer. Okay, so the transformer that we use here is step up, and it is okay increased to 132 kilovolt. Are you getting my point? So now why do we increase this? Because when we are using less voltage, the current becomes high. Okay, so higher voltage leads to low current because the power supply from the power station to our homes are done through the wires, isn't it? So these are wires, conductors of electricity. So when current flows through this, the wire gets heated up. So when you allow high amount of current to pass through these wires, what happens? The wire gets heated up, and when the current is large, the temperature of the wire may lead to such an extent that the wire may get melted. So that is why the power is now stepped up to 132 kilovolt, okay, at the grid substation, okay, so that now at a higher voltage low current can be supplied from grid substation to main substation. So the next station that we have is main substation. Okay, now what happens in main substation? So this 132 kilovolt now is reaching to main substation where step down transformer is used. So step down means ghataunu. Okay, so this 132 kilovolt now is stepped down to 33 kilovolt. Understand? So 33 kilovolt is now we have here in main substation. All right. Now from main substation, okay, it is supplied to two directions or two ways. One here I'm drawing on the right side of the rectangular box here, and one here towards the next rectangular box. Now here 33 kilovolt is supplied to heavy industries. Okay, so 33 kilovolt of energy or power is supplied to heavy industries. Now what are heavy industries? These are the industries which use or which needs huge amount of electrical power or electrical energy. These heavy industries may be oil industries, or it can be mining industries, or steel industries, or chemical industries, or petrochemical industries. And these industries, since they use or need very high amount of electrical power, so the main substation supplies 33 kilovolt of power to the heavy industries. All right. Now the second part from the main substation goes to the intermediate substation. Now what happens here is, here again it is step down, okay, by using a step down transformer to 11 kilovolt. Understand? So this is equal to the one which was generated in the power station. Okay, so 11 kilovolt is now done at intermediate substation. So from this station, two branches comes out. one towards the left, right, I'm drawing here. It is for the light industries. So the intermediate substation, okay, supplies power to the light industries, and then it goes to the city substation. All right, it goes to the city substation. Now 11 kilovolt is supplied to the light industries. So these are the industries which requires less amount of power. These industries may be textile industries, tea industries, leather industries, okay, or manufacturing of computers or parts of computers. All right, so they require less current, so they can be categorized under light industries. So they are supplied 11 kilovolt from the intermediate substation. Now from the intermediate substation, it again goes to the city substation. So now when we hear the word city, so it has come near to us. So at the city, again step down transformer is used to step down from 11 kilovolt, all right, 11 kilovolt to 220 volt. Understand? So this from 11 kilovolt, the power is now dropped to 220 volt. That reaches to us. That is 220 volt is the electrical energy that is reaching to us, that is to the consumer. So this entire process takes place right from the power station to the consumer. So these are the things that happens. Now the things that has to be noted is, first, power is generated 11 kilovolt. It is stepped up. So this is the only place where step up transformer is used. Where? In the grid substation. So grid substation is the place where step up transformer is used, whereas in the rest, in main substation, in intermediate substation, in city substation, in all these three stations, step down transformer is used. That is, the voltage is been dropped from 132 kilovolt to 33 kilovolt, from 33 kilovolt to 11 kilovolt, and from 11 kilovolt to 220 volt. All right. So in the grid substation, the voltage is stepped up at 132 kilovolt. Then it goes to main substation, that is 33 kilovolt, from where the electrical energy is supplied to heavy industries. Then it goes to the intermediate substation, where the voltage is dropped to 11 kilovolt. From here it is supplied to light industries. Then it goes to the city substation, where the voltage is dropped to 220 volt, and then from there it reaches to us for our consumption. All right, so this is how the energy is generated and transmitted from the power generator station to the consumer, that is to our house. Now we will see how the power reaches to us. Okay, so power to our house, how it is reaching to our home. Understand? So the company which is supplying us the current, may supply us the current through overhead wires, which we generally see in our village, in our locality, to pole bada hune tar, or underground cable, or in some of the places you have seen the poles also, like cables also on the pole. So in three ways the company may supply us power: through overhead wires, or cables on poles, cable on poles, or underground cable. So in three ways it may reach us. So I know in our locality we usually get electrical power through overhead wires or through the cable on poles. All right, so the three wires, this overhead wires, pole wires, or underground cables, they usually have three wires. These three wires are live wire. Live wire is also called as phase wire. Okay. And then the other one is neutral wire. Okay. Then you have the earth wire. Live wire is denoted by capital letter L. Neutral wire is denoted by capital letter N. Earth wire is denoted by capital letter E. Is that okay? Now, you must remember that live wire or the phase wire is the one which actually carries current, whereas neutral and the earth, they do not have any current in them, means they are at same potential. So at the company, this neutral wire and earth wire, very important thing to remember. At the company, or the power generating station, or in the local substation, these two wires are connected together and they are maintained at same potential, that is 0. Okay, so they possess 0 volt. Okay, so they have same potential. So out of these three wires, which have same potential? So this is your first assignment for the day. Which two wires have same potential? They are neutral wire and earth wire. They have same potential, that is at 0 volt. So okay, this will be your answer. So you will write this one. All right. Now we saw the three wires. Okay. Now how it reaches us. So before it reaches us, okay, at the pole, suppose say this is our pole. Okay. At the pole, we will have a fuse before it reaches to our home. This fuse is called the company fuse. What do we call it? Company fuse, or sometimes it is also called as pole fuse. Okay. So we are not authorized to handle this. Only the authorized person from the company can handle this fuse, which is called as a pole fuse or the company fuse. All right. Now through this, the wire enters, okay, to a very important section in our house called meter. Understand? So after the company fuse, the cable is connected to a meter. This meter is called as kWh meter, that is kilowatt hour, kWh. So this is a commercial unit of electrical energy, the one we discussed in the last chapter. Electrical energy napne unit is called kWh, kilowatt hour. So I hope you all have seen the meter. So those who have not noticed the meter, I have the the picture of the meter here. I have shown here two picture, one here on the left, one here on the right. So here you can see the difference. Okay, here you have the number which is being displayed here, and here you have a small screen. So this is a digital meter, which nowadays most of our house has this and this one is the old one called as analog meter. Understand? But you can see here you have kWh written here, so this is a kWh meter. Similarly here also you have kWh written. So this is a meter which measures electrical energy consumed by us at our home in a unit, commercial unit called kilowatt hour. So you can also find the meter at your home, okay, and see this kWh written on it. All right, so this is your meter that you have at your home. Okay, you may have the old one called as analog meter or the new one called the digital meter. All right, so after the wire from the pole through the fuse, okay, that is pole fuse, it enters to the kWh meter. Are you getting my point? Now from the kWh meter, it goes to the main switch. All right, where does it go? It goes to the main switch. Okay, it goes to the main switch. Nowadays we do not have the old version of main switch. In place of main switch, we also use a device called ELCB, that is our earth leakage circuit breaker. What is it? Earth. Okay, in place of main switch we use this one, earth leakage circuit breaker. So from the company, the wire is entering to the meter, from the meter is going to the main switch. Okay, from the main switch it goes to the main fuse. Where does it go? Main fuse. Okay, now in place of main fuse we use a device called MCB. This is miniature circuit breaker. Okay, so after the main switch main fuse, it enters to our house for our consumption. So this is how, okay, this is how the electrical, okay, energy from the company reaches to us. Now let me have a quick recall now. First, electricity is connected or coming to us through with the help of three wires: live, neutral and earth. Before it enters to house, it passes through a fuse on the pole, which is called as company fuse or pole fuse. It goes to the then meter, kWh meter. Okay, through the meter it goes to the main switch. Okay, and through the main switch it goes to the main fuse. Main fuse leather nowadays we also called as ELCB. It is called earth leakage circuit breaker, and MCB, which is called as main fuse. All right, so this is it for today. Okay, and before I wind up, I'll give you some assignment for the day. Assignment number 1 I've already mentioned here within the video. Assignment number 2 is why electric power is generated at 11 kilovolt and not below 11 kilovolt or above 11 kilovolt. That is number 2. Number 3 is give me some examples. Okay, give or write some examples of heavy industries and light industries. Okay, and number 4 assignment is how many wires, okay, supplies electrical energy to our home. Name them and also write the abbreviation. All right, so this is it for today.